Hello, my dear friends. How are you all? I hope you all are good and fine. So, my dear friends, you are very welcome in our lecture number 7 of Introduction to Trigonometry. Okay, my dear friends. So, I hope you enjoyed our lectures. Okay, so my dear friends, without wasting the time, let's start. So now here we are going to continue our previous topic, law of tangents. Okay, so in previous lecture we learned the sine laws, cosine laws. Now in this lecture, so law of tangents we are going to continue. Okay, so now what is law of tangents? Okay, so the law of tangent describe the relation between difference and sum of sides of a right triangle and tangents of half of the difference and sum of the corresponding angles. Okay, so my dear friends, it represents the relationship between the tangents of two angles of a triangle and the length of the opposite sides. So the law of tangent is also applied to a non-right triangle. So this law, it is this law, so it is also applied for what? Non right angle triangle. Okay, so it is equally as powerful link the law of sines and the law of cosines. It can be used to find the remaining parts of a triangle if two angles and one sides or two sides of one angle are given, which are referred to as the side angle side or angle side angle. Okay, yeah. So now to understand this law in a better way, we need to some pieces of information for a general triangle. Even it may or may not be a triangle. The four cases involved are like, so the four cases are, first is two sides and one opposite angle. Two side and one opposite angle. Okay, and second case, one side and two opposite angle. Two opposite angle. This is what? This is side angle side. This is side angle side. And this is what? This is angle side angle. Okay. Now the third case is three side. And fourth case is two sides and the angle between them. Okay, my dear friends, I hope you understand these things. So now let's move on. Yes, formulas for laws of tangents. Formulas for laws of tangent. Now we are going to see the formulas of this law. Okay, so let us assume a right triangle ABC. Okay, let us assume that okay, A, B, C, and this is angle A, angle B, angle C. This is A, B, C. These are the sides. So angle A, angle B, and angle C, okay, are the angles of triangle ABC, and A, B and C, these are the what? Sides of triangle ABC. Okay, my dear friends, I hope you understand these things. So according to this law of tangent, okay, we have to follow three relations. What are these relations? So let's see. So the first relation is A minus B upon A plus B is equals to tan A minus B divided by 2 divided by tan A plus B divided by 2. So this is the first law of tangent. This is what? This is first law of tangent. A minus B upon A plus B, which is equals to tan A minus B divided by 2 and tan A plus B divided by 2. Okay, this is the first formula. Now second formula is B minus C upon B plus C, which is equals to tan B minus C, capital B minus capital C, divided by 2 divided by tan B plus C divided by 2. So this is the second formula of this law. Okay, my dear friends. Now the third formula is similar, as we can write it as C minus A and C plus A. These are the sides and here are the angles. So this will be tan C minus A divided by 2. Okay, divided by tan C plus A divided by 2. So these are the formula of sine law. So my dear friends, they are very important formulas. Okay, so now, okay, so I hope you remember these formulas. So there is not a big deal. Okay, simple thing is A minus B upon A plus B. Okay, and here is B minus C upon B plus C, and here is C minus A upon C plus A. Okay, so this is the relation between the sides and the angle just only. Okay, not a rocket science. Okay, so now, and we know that the identity is tan minus theta. What is tan minus theta? Tan minus theta. So we know this is minus tan theta. In previous lecture we learnt this identity. Okay, identity of the opposite angles. Okay, so tan minus theta is what? Minus tan theta. So in these formulas, if in these formulas minus will become, then we can switch the order of letters in the above law of tangent formulas, and we can be written as so after modification of first formula, there is a fourth formula, B minus A upon B plus A, which is equals to tan B minus A divided by 2 upon tan B plus A divided by 2. This is a fourth formula. Similarly, we can modify second and third formula. Similarly, so the fifth formula is C minus B divided by C plus B, tan C minus B divided by 2 and tan c plus b divided by 2. Okay, and sixth formula is a minus c upon a plus c, which is equals to what? Which is equals to tan a minus c divided by 2 is equals to tan a plus c divided by 2. Okay, my dear friends, so these formulas very important, so you have to be learned. Okay, yes. So the formula 1, 2 and 3 are used. So here I am writing the condition. So the formula 1, 2 and 3 are used when a is greater than b and b is greater than c and c is greater than a. Okay, then we can use this formula. Okay, my dear friends, and this formula can be used, the formula 4, 5 and 6 can be used when b is less than a in triangle 4 or in formula 4, and in formula 5 c is greater than b, and in formula 6 a should be greater than c. Okay, if this condition is satisfied in their respective formulas, then we can use these formulas. Okay, my dear friends, I hope you understand these things. So now we are going to see the proof of laws of tangent. Okay, the proof of laws of tangent. Okay, so now we know that a minus b upon a plus b is equals to tan a minus b upon 2 divided by tan a plus b upon 2. Okay, we know that. Now for proving these formulas, we have to use the law of sine. So from the law of sine, what is the law of sine? A upon sine b, a upon sine a is equals to b upon sine b is equals to c upon sine c. Okay, now we have to use these first two conditions. Use first and second condition, means these two conditions. So we get a upon sine a is equals to b upon sine b, which is equals to, we are taking k as a constant. Okay, so we get a is equals to k sine a and b is equals to k sine b, k sine b. This is sine b. Okay, my dear friends. So my dear friends, now we have to add and subtract this equation. Now first we have to add this equation and then we have to subtract this equation. Okay, so now then it will become a minus b is equals to k sine a minus k sine b. Then it will become a minus b, k is a common, and sine a minus sin B. Similarly, when we add this equation, then we get k sin A plus sin B. Okay, my dear friends, I hope you understand these things. So now, if we divide this equation, this is equation number 1 and this is equation number 2. So now, my dear friends, divide this equation, we get divide this equation, we get what? A minus B divided by A plus B, which is equals to k sin A minus sin B, okay, divided by k sin A plus sin B. Okay, this k will be cancelled, so we get sin A minus sin B divided by sin A plus sin B. This is equation 3rd. Okay, now we know that the formula of like we know the identity is sin A minus sin B. In previous lecture we learnt about this identity, which is 2 cos A plus B divided by 2 sin A minus B divided by 2. Okay, and sin A plus sin B is 2 sin A plus B divided by 2 cos A minus B divided by 2. Okay, so now we are using these identities and substitute in the formula in this equation number 3rd. So it will become, after putting these values in equation 3rd, then the equation 3rd will become A minus B upon A plus B is equals to 2 cos A plus B divided by 2, okay, sin A minus B divided by 2 upon 2 sin A plus B divided by 2 cos A minus B divided by 2. Okay, now we know that tan A is what? Tan A is sin A upon cos A. Okay, so in this case we have A plus B upon 2, okay, and here is A, we have A minus B upon 2. So we can write it as 2 will be cancelled. So we get what? We get tan A plus B upon 2. Okay, wait, this is not plus, this is, because sin upon cos, this is a sin upon cos, so it will get minus A minus B upon 2 upon and this is cos upon sin, then the tan will become in the denominator, and this will become tan A plus B upon 2. Okay, so the final formula is A minus B upon A plus B is equals to tan A minus B upon 2 divided by tan A plus B upon 2. Okay, my dear friends, so this is our final formula and hence proof. So similarly we can also prove, the formula of sec 2, 3rd, 4th, 5th and 6th, like this. Okay, so my dear friends, this is the method, this is the proof of the tangent rule. Okay my dear friends, I hope you get this point. So now let's move on. Yes, now we are going to discuss finally trigonometry application. Okay, what is trigonometric application? So you know, trigonometric is one of the most important branch of mathematics. Okay, so some of the applications of trigonometry are measuring the heights of towers and big mountains. What is measuring the heights, measuring the heights of towers or big mountains. Okay, and second application is determining the distance of the shore from the sea, determining the distance of the shore from the what? From the sea. So now the third point is find the distance between two celestial bodies. Third point is what? Third point is finding the distance between two celestial bodies. Okay my dear friends, and fourth point is determining the power output of solar cells at different inclination. Determining the power output, determining the what? Determining the power output of solar cells. Okay, of solar cells panel at different inclination. Okay my dear friends, and fifth point is representing different physical quantities such as mechanical waves, electromagnetic waves, etc. Representing different physical quantities such as what? Mechanical waves, electromagnetic waves, etc. Okay my dear friends, so I hope you understand the application of trigonometry. Okay, so from these application we can say that trigonometry has its involvement in a major part of our day-to-day life and much more. Okay my dear friend, so now we are going to discuss some questions. Okay, so our theoretical part is completed. Now we are going to discuss a lot of questions. Okay, yes, so the question number One is express the trigonometric ratios sin A, sec A and tan A in terms of cot A using the identities. Using what? Yes, using the identities. So my dear friends, so to convert the given trigonometric ratios in terms of cot functions, we have to use the trigonometric formulas. Okay. So we know that. So we know that cosec square A is equals to 1 is equals to what? 1 plus cot square A. Okay, we know that. So cosec formula in the inverse of sine function, it is written as, we can write it as 1 upon sine square A. Okay, which is equals to 1 plus cot square A. Okay, now so it will become sine square A, which is equals to 1 upon 1 plus cot square A. 1 plus cot square A. Now take the square root on both the sides. We are taking the square root on both the sides. So we get sin A is equals to plus minus 1 upon under root 1 plus cot square A. 1 plus cot square A. Okay, so this equation defines the sine function in terms of cot. So this is the trigonometric ratio of sin A in terms of cot. Okay, understand? So now we have to express sec formula in terms of cot. Okay, so now we know that from the above condition, sin square A is equals to 1 upon 1 plus cot square A. We already know. Now we can write sin square A as 1 minus cos square A, because we know that cos square A plus sin square A is equals to 1. You know, and this is 1 upon 1 plus cot square A. Okay, so now we are shifting and we are rearranging them. We get cos square A is equals to 1 minus 1 upon 1 plus cot square A. Okay, and if we take the LCM, 1 plus cot square A, we get 1 plus cot square A minus 1, and this minus 1 and 1 will be cancelled. We get cot square A upon 1 plus cot square A. Okay, now we know that since cos A is equals to 1 upon sec A. Okay, so we are putting this in equation in above equation. So we get 1 upon sec square A, we get cot square A upon 1 plus cot square A. Now reverse the denominator and numerator. Okay, now we have to do the reciprocal. So we get sec square A is equals to 1 plus cot square A upon cot square A. Okay, my dear friends, now take both the side as the under root. So we get what? We get our final answer, which is sec A is equals to plus minus under root 1 plus cot square A divided by cot A. So this is the formula. This is the this is sec A in terms of cot A. Okay, so now we have to express cot function in terms of tan function in terms of cot function, which is very easy. Okay, and this is what, this is the identity. So we know that tan A is equals to 1 upon cot A. Okay, my dear friends. Okay, yes. So let's move on to the next question. Now we have to evaluate sin square 63 degree plus sin square 27 degree upon cos square 17 degree plus cos square 73 degree. Okay, so in this case we have to apply the formulas only. Okay, so to simplify this, convert some of the sine function ratio, cos functions and cos functions into sine functions. Okay, so now it will become, now we can write here it as sine square, it can be written as 90 minus 27 degree, because if we subtract it we get sin 63 degree. Okay, plus this is sin square 27 degree. Okay, now upon this will become cos square 90 minus 73. If we subtract it, then we get same 17 plus cos square 73 degree. Now using the complementary angles, identity of complementary angles, we get this will become cos square 27 degree. Okay, plus sin square 27 degree. Okay, and this will become sin square 73 degree plus cos square 73 degree. Now we know that sin square A plus cos square A, which is equals to 1. So this equation becomes 1 and this equation again becomes 1. So we get what? We get 1 upon 1. So the answer is 1. Answer is what? 1. This is our answer. So I hope, my dear friends, you understand this concept. So now let's move on. Yes, question number 3 is find the value of this. Okay, now first is 9 sec square A minus 9 tan square A. Okay, now we have to find this value. So first of all, take 9 as a common and we have sec square A minus tan square A. Okay, sec square A minus tan square A. Now since we know that what, the identity sec square A is equals to 1 plus tan square A. If we shift tan square A to the LHS, we get sec square A minus tan square A equals to 1, which is equals to what? 1. So we get 9 into 1, which is equals to 9. Very easy question, my dear friends. Okay, so now let's move on. Yes, now the second question is 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta. Okay, now we have to solve this. First of all, we know that tan theta is equals to sin theta upon cos theta. Now convert these equations in terms of sin and cos theta. Okay, and we know that cot theta is equals to cos theta divided by sin theta. Okay, and we know that sec theta is equals to 1 upon cos theta and cosec theta is equals to 1 upon sin theta. Okay, now put these values in this equation. So we get 1 plus sin theta upon cos theta plus 1 upon cos theta multiply 1 plus cos theta upon sin theta minus 1 upon sin theta. Okay, my dear friends, I hope you get this point. Now we have to simplify this question. We get from this will become cos theta. We are taking cos theta. So this is cos theta plus sin theta plus 1. Okay, cos theta plus sin theta plus 1. And this will become, here is sin theta is the LCM. So sin theta plus cos theta minus 1. Okay, my dear friends. Yes. So now this will become, now if you see in this equation, this is like A and B. Okay, and same A and B is same. So this is the formula of A plus B and A minus B. So what is the formula? So the formula is A square minus B square. Okay, and in this case what is A? Cos theta plus sin theta. Okay, and what is B? 1. So we can write it as cos theta plus sin theta whole square minus 1 square divided by cos theta into sin theta. Okay, now we have to expand this equation. So we get cos square theta plus sin square theta plus 2 cos theta sin theta minus 1 divided by cos theta sin theta. Now this expression will become 1 because cos square theta plus sin square theta is 1. So we get 1 plus 2 cos theta sin theta minus 1 divided by cos theta sin theta. And this one will be cancelled. So we get 2 cos theta sin theta divided by cos theta sin theta. Now in this case cos theta cancel, sin theta cancel. So we get 2 as the answer. So we have answer is 2. Okay, my dear friends. So my dear friends, this is very easy question. So you have to be just follow the steps. Okay, and you have to know the identities. Okay, yes. So now prove the following identities where the angles involved are acute angles for which the expressions are defined. Okay, so we have cosec theta minus cot theta square is equals to 1 minus cos theta upon 1 plus cos theta. Okay, so to prove this, first take the LHS of this equation to prove the RHS. Okay, so now we have to prove LHS equals to RHS. So first we are taking LHS, left hand side. Okay, so now we have what? We have cosec theta minus cot theta whole square. We have this. Okay, now the above equation is in the form of like this, a minus b whole square. And what is the formula? We know that a square plus b square minus twice of ab. Okay, so we can write it as cosec square theta plus cot square theta minus twice of cosec theta and cot theta. Okay, now applying the corresponding inverse function and equivalent ratio to simplify, like we know that cosec theta is equals to 1 upon sin theta and cot theta is equals to cos theta upon sin theta. So putting these values in this equation, we get 1 upon sin square theta plus cos square theta upon sin square theta minus 2 into 1 upon sin theta into cos theta divided by sin theta. Okay, understand? So now it will become, so in the denominator there is a sin square theta, so we are taking sin square theta as a LCM, and here is 1 plus cos square theta minus 2 cos theta minus 2 cos theta. Okay, so this is the formula of, yes, if we observe this 1 plus cos square theta minus 2 cos theta. Okay, so this is the formula of 1 minus cos theta whole square. If we expand this, we get this. Okay, and we can write it as 1 minus cos square theta. 1 minus cos square theta, we can write it easily. So this equation will become, here we have 1 minus cos theta whole square, and we have 1 minus cos square theta. So we can write it as also upon 1 minus this is the formula like a square minus b square. 1 can be written as a square, so a square minus b square, so it will become a plus b and a minus b. So 1 minus cos theta into 1 plus cos theta. Okay, my dear friends, so from this one expression, the above one expression will be cancelled. So we get 1 minus cos theta divided by 1 plus cos theta, which is equals to RHS. So this is a required result and hence proof. Okay, my dear friends, I hope you get this point. So now my dear friends, this is enough for today, and we will meet in the next lecture with the amazing topic. Okay, so I hope you enjoyed this lecture. So thank you very much guys for listening me, and take care and goodbye.